This part of the notes, we're going to look at applications and maximizing profit and revenue. But before we do that, we need to look at this second derivative test that we can do on finding an absolute extrema. What happens is if we only have one critical number, we can take the second derivative, and if it is greater than 0, the second derivative at that critical number is greater than 0, then it's an absolute min. If it's less than 0, then it's an absolute max. And we're going to use that second derivative test to test our critical value. So for example, we're going to find the revenue function, and if you recall, revenue is the price demand times X. So let's find the revenue function. It's going to be 10x minus 0.001 x squared. Wants to know what price we should charge to maximize revenue and what is the maximum revenue. So in order to find the maximum revenue, we need to find our first derivative to find the critical value. Set it equal to 0. Solving, we will get x equals 5,000. Right? Add 0.002x to both sides and then divide by 0.002. We take the second derivative, and when we take the second derivative, we get negative 0.002. And this just tells us that it's less than 0, and we are a max. So this is a max value. Okay, so what is the maximum revenue? You just substitute 5,000 into our revenue function, and when you do that, you get 25,000. And what is the price that we should charge? Substitute 5,000 into our price demand function, and you get $5. So when we sell 5,000 markers, we'll reach our maximum revenue at 25,000 if they're sold for $5. Okay, so there is a problem here for you to try. And it's just like this previous one. You're giving a price demand, and you need to find the maximum revenue and the price that you should charge the maximum revenue. Okay, so that was revenue. Let's look at maximizing profit. So if you recall, profit equals revenue minus cost. So we're going to use our previous revenue from the example that I did, and that was 10x minus 0.001 x squared, so that we can now come up with a profit function, which is revenue minus costs. Remember that you have to subtract this whole thing. I already distributed. So you get 8x minus 0.001 x squared minus 5,000. Okay, so just like before, and take the derivative. Set it equal to 0. Solve for x. Second derivative, get negative 0.002, which is less than 0, so it's a max. Profit, when we sell 4,000, substitute it back into our profit function. You will get $11,000. The price, okay, so that price function from that prior problem was P equals 10 minus 0.001x. And the price then that we should charge is $6. So very similar to our maximizing revenue, only use the profit function. Okay, so you have the same type of problem. I'm going to give you, there's your cost function. Just so you have it in case you didn't have it written down. Price is, and the revenue that you should have used and again, maximum profit and what should you charge, how many.